Let's look at intervals where a function is increasing, decreasing, or constant. For example, the graph of the function f is shown below. Let's find the intervals where f is increasing, decreasing, or constant, and then we'll find the domain and range of f as well as any x or y intercepts of its graph. Now we have the following. A function f is said to be increasing or strictly increasing on an interval if for all a and b in that interval, where a is less than b, the y value at a, namely f of a, is less than the y value at b, namely f of b. And what does that mean about the graph of the function? Looking down here in this figure, it means that the graph of the function is rising as we look from left to right. And a function is said to be decreasing on an interval if the y value at a is larger than the y value at b, for any a less than b. And looking down here, what does that mean about the graph? It means the graph, looking left to right, is falling. And a function is said to be constant on an interval if for all a and b in that interval, the y value f of a is equal to the y value f of b. And looking at the graph will be horizontal on that interval. All right, let's start with increasing. Looking at the graph of our function here, we see that the graph is not rising on any interval. So therefore, our answer here would be none, since the graph is never rising. All right, where is f decreasing? Looking at our graph, we see that the graph is falling here as well as here, which corresponds to these intervals here and here. That is, the interval over which f is decreasing is -3 to -2, union 1 to 3. Now, what about where this function is constant? Looking at our graph here, we see that the graph is horizontal here, here, and here, which corresponds to the interval here, here, and here. Namely, -7 up to -3, union -2 up to 1, union 3 up to 5. All right, and we're also asked to find the domain and range of f as well as any x or y intercepts of its graph. So looking at our graph, we see that the domain is equal to the interval from -7 up to 5. Remember that the domain is the set of all possible x-coordinates of points on the graph. And the range is the set of possible y-coordinates of points on the graph. And looking at our graph, the y values range from 1 up to 6. And what about x and y intercepts? This graph never touches the x-axis, so there's no x-intercepts. And it crosses the y-axis right here, which is y equal to 4. So the y-intercept is y equal to 4. All right, let's look at another example. Here's the graph of f, Again, we'll determine the intervals where f is increasing, decreasing, or constant, and then we'll find the domain range as well as any x or y intercepts. Again, a function is increasing on an interval if for every a and b in that interval with a less than b, then the y value f of a is less than the y value f of b, and the graph will be rising on that interval. And the function is said to be decreasing on the interval. It's the other way around. The y value at a is greater than the y value at b, and the graph is falling. And the function is said to be constant on an interval if for all values in that interval, f of a is equal to f of b, and the graph is horizontal on that interval. So where is our graph increasing? Looking at the graph, we see it's rising here, which corresponds to this interval here. Or -2 up to 3. Now what about decreasing? Looking at our graph, the graph is not falling on any interval, so this would be none. And finally, on what intervals is our function constant? We see that our graph is horizontal here as well as here, which corresponds to this interval as well as this interval. That is, it's constant from -infinity up to 2 union 3 to infinity. Now notice in both of these examples, we've been writing these intervals as open intervals. These terms, increasing, decreasing, and constant, are defined in terms of intervals, not pointwise, but in terms of intervals. Now we could have included either or both of any of these endpoints, and our answer would be correct. But by convention, most authors will state these intervals as open intervals. All right, it still remains to find the domain range and any intercepts of the graph. So the domain here is a set of all x coordinates of points on the graph. And looking here, every x value will be in the domain. That is, the domain is the interval from -infinity to infinity. However, with the range, we're missing this big piece here, aren't we? And because of this open circle here, there is no point on the graph that has y coordinate equal to 1. But this point is closed, which means there is a point on the graph where y is equal to 3. And in fact, y is also equal to 3 at every point to the right of this on the graph. But not only that, there's also no points on the graph that have y coordinates larger than 3. And there's no points on the graph that have y coordinates less than -4. That is, our range is the interval -4 up to 1 open parentheses union the value 3, which we can write as the interval 3 to 3. All right, we see that we have both an x-intercept and a y-intercept. The x-intercept is 2, and the y-intercept is -2. And this is how we work with increasing, decreasing, and constant intervals, as well as domain range and intercepts. Thank you, and we'll see you next time.